Hello everyone, today I'll be going through all of the challenge questions in Edexcel's Applied Year 1 textbook, and this is the second video in the series for statistics, and we're looking at chapter 5 today. Okay, our first question is from exercise 5a. Samira picks one card at random from group A and one card at random from group B. She records the product y of the two cards as a result of her experiment. And given that x is an integer and that the probability y is even is equal to the probability that y is greater than or equal to 20, find the possible values of x. So we can start by drawing a table of the possible outcomes. So if we have a at the top here and b down the side, and we're multiplying. So the possible cards we can pick for A are 2, 7 and 5, and for B they are 4 and x. So filling in this table, we get 8, 28, 20, we have 2x, 7x and 5x. Okay, so we're told that the probability y is even is equal to the probability y is greater than or equal to 20. Okay, and looking at the table, we can see that 8, 28, 20 and 2x are all even. And what we can see is that if x is odd, then the probability that y is even is 4 out of 6. And if x is even, then the probability is 6 out of 6. All of them will be even. We know that the probability that y is greater than or equal to 20 can't be equal to 6 over 6 or 1 though, because 8 here is not greater than or equal to 20. So we know that x isn't even, and so x is odd, and the probability that y is even is 4 out of 6. So we know that the probability y is greater than or equal to 20 is 4 out of 6. So 4 of our products y have to be greater than or equal to 20. So we've got 28 and we've got 20. We know that 8 isn't greater than or equal to 20. So that means 2 of 2x, 7x and 5x must be greater than or equal to 20. And because we know that 2x is less than 5x, which is less than 7x, therefore 5x and 7x must be greater than or equal to 20, and 2x must be less than 20. So we've got 2x must be less than 20, and we also have that 5x and 7x must be greater than or equal to 20. Okay, and we know that if 5x is greater than or equal to 20, then 7x, which is greater than 5x, must also be greater than or equal to 20. So the only inequality we need to consider here is that 5x is greater than or equal to 20, and that will cover 7x as well. So here we have x is less than 10, and here we have x is greater than or equal to 4. So we know that 4 is less than or equal to x, which is less than 10. And we know from here that x must be odd, so therefore the only possible values of x are 5, 7 and 9. And that is our final answer. The next question is from exercise 5b. A Venn diagram shows the probabilities of a group of children liking 3 types of sweet. Given that the probability of B equals 2 times the probability of A, and that the probability of not C is equal to 0.83, find the values of P, Q and R. So we're given that the probability of B is equal to 2 lots of the probability of A, and know the probability of B is equal to all of the elements inside the circle B summed, so that's P plus Q plus 0.05. And doing the same for the probability of A, we get 2 lots of 0.15 plus P. Okay, and multiplying by the 2 on the right hand side, we get P plus Q plus 0.05 is equal to 0.3 plus 2P. And therefore we get Q minus P equals 0.25. Okay, the second bit of information we're given is that the probability not C is equal to 0.83. And so to find this probability, we just have to do 1, subtract everything that's inside the circle C. So that is 1 minus r plus 0.05 is equal to 0.83. So therefore 0.95 minus r is equal to 0.83 and r is equal to 0.12. Okay, and now we want to find another equation in terms of q and p, so we can solve them simultaneously and get our values of p and q. And one fact that we can use to get this other equation is that the sum of all of the elements in the entire set has to be equal to 1. So we have 0.15 plus p plus q plus 0.05 plus r plus 0.2 must be equal to 1. So we have p plus q, and we have 0.15 plus 0.05, which is 0.2. We have another 0.2, so we've got 0.4. And we know r is equal to 0.12, so plus 0.52 is equal to 1. So we have p plus q is equal to 0.48. Okay, we have our second simultaneous equation. So if we call this 1 and we call this 2, if we do 1 plus 2, then the p's will cancel and we'll get 2q is equal to 0.25 plus 0.48, which is 0.73. So we get q is equal to 0.365. And plugging that back into equation 1, we have p is equal to q minus 0.25. So p is equal to 0.115. And those are our two answers. Okay, moving on to exercise 5c. A and B are independent events in a sample space S. Given that A and B are independent, prove that for part A and not B are independent. So, if we know that A and B are independent, that means the probability of A intersection B, so the probability of them happening at the same time, is equal to the probability of A times the probability of B. Okay, and if we let the probability of A equal, let's say, P, and the probability of B equal Q, then we can write this as PQ. And now we want to find the probability of A intersection not B, and if that is equal to the probability of A times the probability of not B, which is equal to P times 1 minus Q, which is equal to P minus PQ. So, if this is true, then we know that A and not B are independent. Okay, so we need to find the probability of A intersection not B in another way. And if we visualize this on a Venn diagram, if we have A here and B here, then the probability of A intersection not B, if I shade in A in red here, okay, and I'll shade in not B in green, so everything that's not inside B, okay, you can see that their intersection point is this sort of moon shape around here. And that is where they intersect. So we have that the probability of A intersection not B is equal to the probability of A minus the probability of A intersection B. And so we get that is equal to P minus PQ. And we've shown that the probability of A intersection not B is equal to the probability of A times the probability of not B. So therefore, A and not B are independent. Okay, for part B, we need to show that not A and not B are independent. So, doing the same thing as before, if they are independent, we have that the probability of not A intersection not B is equal to the probability of not A times the probability of not B, which is equal to 1 minus P times 1 minus Q. And that is equal to 1 minus P minus Q plus PQ. So again, we need to find the probability of not A intersection not B in a different way, and we'll do that using a Venn diagram. So if we have A here and B here, so if I shade in not A in red again, so that's everything but A, and then everything but B in green. Okay, and you can see that their intersection is everything apart from these two circles here. So everything outside of these two circles has red and green in it. So we have the probability of not A intersection not B is equal to everything, so 1, minus the probability of A, minus the probability of B, but that means we've taken away this little intersection point twice, so we need to add that back on. So plus the probability of A intersection B. And this is equal to 1 minus P minus Q plus PQ as required. So as the probability of not A intersection not B is equal to the probability of not A times the probability of not B, they are independent. Okay, and finally, for mixed exercise 5, the members of a cycling club are married couples. For any married couple in the club, the probability that the husband is retired is 0.7, and the probability that the wife is retired is 0.4. Given that the wife is retired, the probability that the husband is retired is 0.8. Two married couples are chosen at random. Find the probability that only one of the two husbands and only one of the two wives is retired. So if we draw a Venn diagram to represent this situation, we have two circles. Okay, and if we think about each of the couples as a pair, we can say that this circle represents the probability that the husband is retired, and the right circle the wife. So the intersection of these two circles is the probability that the husband and the wife is retired, and the outside area is the probability that neither are retired. Okay, and we can label these sections of the Venn diagram A, B, C, and D just to make it easier to reference in equations. Okay, so first of all, we're told that the probability that the husband is retired is 0.7, so A plus B equals 0.7. And we're also told that the probability the wife is retired is 0.4, so B plus C equals 0.4. And we're also told that given that the wife is retired, the probability that the husband is retired is 0.8. So we can restrict the sample space. So we know that the wife is retired, so we only need to look at this circle here. And so the probability that the husband is retired is B over the entire circle, so B plus C. And we know that that is equal to 0.8. Don't worry if you don't quite get that step, because you'll learn more about conditional probability in year 2 statistics. Okay, so rearranging, we get B equals 0.8b plus 0.8c, so 0.2b is equal to 0.8c, and therefore B is equal to 4c. Okay, so solving these two equations here, simultaneously, we can put B equals 4c into the top one, so we get 4c plus c equals 0.4, and therefore 5c equals 0.4, so c equals 0.4 divided by 5, which is 0.08. Okay, 0.08. Now we know that b equals 4c, so b equals 4 times 0.08, which is equal to 0.32. And finally, we can find the value of a using the top equation here. So a equals 0.7 minus b, which is 0.32. So we get that is equal to 0.38. And finally, to find the probability D, we do 1 minus 0.38 minus 0.32 minus 0.08 to get 0.22. Okay, and that is our Venn diagram complete. Okay, and now two married couples are chosen at random. Find the probability that only one of the two husbands and only one of the two wives is retired. Okay, here there are two possible cases. So case 1 I'll do in red. And that is that one couple has both husband and wife retired, and the other couple has neither retired. So that'll give us our one husband and one wife retired. And our second case, case 2, is that one couple has just husband retired, and the other couple has just the wife retired. Okay, so for case 1, one couple has both husband and wife retired and the other has neither retired. Probability of this happening is 0.32, so that's the intersection, so they're both retired, times the probability that neither are retired, so that's 0.22. And we're multiplying that by 2 because we can swap around the couples and it'll be the same thing. And for case 2, we have the probability that one couple has just the husband retired, so that's 0.38, times the other couple has just the wife retired, which is 0.08. And again, we have to times this by 2 because it can be the opposite way around for the couples. Okay, and so our total probability that only one husband and one wife are retired is equal to 2 times 0.32 times 0.22 plus 2 times 0.38 times 0.08, and that gives us 0.2016, and that is our final answer. And that is the end of the challenge question walkthrough for the Applied Year 1 textbook, Statistics Part 2. And I hope to see you in Part 3.